back. So we have our fourth project for CECS 174, and today's guideline is that we have to write a program, and as it says that we have to have the user input an integer, and the program will output a additive persistence, additive root, multiplicative persistent, as well as a multiplicative root. So basically, if you don't know, this is basically an example of what it should be doing. It's if you put in integer 1, 2, 3, 4, 1 plus 2 plus 3 plus 4 plus 10, integer is 10, and then 1 plus 0 is 1, so that kind of style. So the guidelines is that a program must ask the user for an integer, and the user must input an integer, and then it should give out the additive root, all that kind of stuff. And it's a loop that the user has to continue until the user doesn't want to go anymore. So the only way for the user to quit the program is by putting in a negative number. All right, so we have an example output, but first let me run you guys through the code. So we are going to be using a while loop so the user can continue. Let me just get out of this real quick. Okay, so let's start with the while loop. So since we need the user to keep looping the code until they're done with the code, it's going to be a while loop. So the first line is the while loop, while the next line is where the user would be asked to input their numbers. So it says please input an integer, and then if they input a negative number, the entire program will quit, and then loop is finished. So that's why I said if user number is less than 0, like a negative number, it basically says thanks for playing and then goodbye. All right, next part is the else statement. So basically we had the multi-root, the multiplier, the additive root, and the additive per is all equal to 0. We're just setting variables, as well as I'm just going to use an easier variable. So I replace user num with just num by itself. All right, so the first half, we focus on the multiplication loop. So we said while the number is not equal to 0, and then we just set more variables, count equals 0, the mult equals 1, and then another variable, number 2 equals num. So basically, the loop continues while the negative integer, the loop keeps going until a negative integer is input, basically. So basically, to find out the multiplier as a multiple root, this is how you would write the code. Mult is multiplied equal to number 2 percent 10, and then you just count plus or equal 1, and then we do a break after all this. All right, so this is basically how you wrote the multiplication part, and then you do the exact same thing for addition, except it's going to be a sum now instead of a multiplier. So let's see. Basically, yeah, this is the exact same thing. You can write the exact same code, except that it changes just a little bit because of you're changing it into a sum, as well as the additive per is it's now additive instead of a multiplier. So yeah, it's the exact same thing. It's just the multiplication and addition is just the words change. All right, so now that we wrote our statements for the loop for multiplication as well as addition, we just move down to the final part, which is the print statements. So in the format for an integer, and then you input the number. For example, I put in a large number. It's say for an integer, large number, and it calculate the additive persistence, the additive root, multiplicative root persistent, and the multiplicative root. All right, let's try this real quick. So in this guideline, their example problem was 1, 2, 3, 4. Pretty simple. So let's just input 1, 2, 3, 4. Basically, what this is saying, multiplication loop. 1 times 2 is 2, times 3 is 6, times 4 is 24. We got the multiplication loop. 2 times 4 is 8. That's basically it. Yeah, we got it. Addition, 1 plus 2, 3. Plus 3, 6, plus 4, 10. Addition loop, 10. 1 plus 0, 1. So with the integer 1, we have the additive persistent to be 2, additive root to be 1, multiplicative persistent to be 2, multiplicative root to be 8. And that basically matches the exact same thing as her rubric guidelines. 2, 1, 2, 8, as well as showing the 24, 8, 10, and 1. So basically the 1, 2, 3, 4 guideline works out. Let's try the new example. Let's do 999. All right, we got the exact same thing. You can calculate 9 times 9 times 9. That would give out 729, and then 126 if you, let's see, multiply these out. Yes, 7 times 2 times 9. Same thing, just keep going until there's a single digit left. And then same thing for addition loop. You just add 9 plus 9 plus 9. 2 plus 7 is 9. And then with the final integer would be 9, you have the additive persistent, additive root, multiplicative persistent, and the multiplication root. Pretty simple. So that's the exact same thing as outputted right here. All right, let's see what should happen if you input a negative number. So pretty simple. Let's just input -1. All right, simple. If you put in -1, it just gives you the exit output, which says, thanks for playing with numbers, goodbye. So yeah, that's basically the code I will show you. Let's just run it real quick one more time. Let's do a simple number 157. All right, some multiplication loop, 1 times 5 times 7, 35. And then 3 times 5, 15. 1 times 5 is 5. Addition loop, 1 plus 3 is 4. For integer 4, it gives you the additive root, persistent, multiplicative persistent, as well as multiplicative root. So yeah, this basically just keeps continuing like a loop until, let's say, I put in -600. 6,000. All right. So in the end, even if it's a whatever negative number, it'll just say thanks for playing, and you're basically done. So yeah, this is the code. It's in a while loop, and it doesn't use any break statements. So I think this code is the right way to solve this project. So I can run it through one more time. So the first part was the while statement to make sure everything runs in a while loop. Then the users input their integers. Then we have the multiplication loop, where I assign variables as well as to calculate the multiplicative roots and the multiplicative integer. And it's exact same thing but for addition loop. And finally, the print statements. So yeah, thank you so much for watching.